One of the main reasons to take a landscape perspective to ecosystem ecology is really to think about the interactions among ecosystems or different patches. And in this section, we're going to cover patch interactions on the landscape. Interactions among patches on the landscape influence the functioning of individual patches and the landscape as a whole. Now, when we have the word patches here, really just substitute ecosystems. And that gives it new relevance. And think about the reason why we're doing this and taking a look at spatial variation, in part is because we might want to get better averages. And that was the idea of hotspots. But we also know that the functioning of an individual ecosystem over certain timescales, depending on the process, is going to depend on interactions with adjacent areas. And it's these interactions among ecosystems that determine the functioning of individual ecosystems. So to think about those interactions, we're just going to start with the question of what moves among patches. If there are going to be interactions, something has to move back and forth, some signal or energy and materials that's going to influence the functioning of those systems. So for example, water is going to move among patches, and there's going to be downstream, downwind effects of changes in how water are being used. Organisms are also a good candidate to think about, and it's the movement of organisms that across ecosystems, both their propagules and the materials they carry with them, for example, that impact the dynamics. Disturbances also can be thought of as being affected by adjacent areas, and we see how disturbance can propagate itself through the environment, whether that's a biotic or an abiotic disturbance. So to start, we can give an example of topographic redistribution and think about water. So when we start to think about patches, and we're going to take a look at processes that occur in uplands and in lowlands, for example, if there's subsurface flow of water or overland flow, changes in the vegetation, for example, in the uplands, are going to have downstream effects, whether that's water moving in overland flow or in groundwater. In addition, you're going to have differences in evapotranspiration that often have consequences downwind. And for areas, at least over larger scales, putting water vapor into the atmosphere is going to change cloudiness and precipitation also. So water is going to be something that moves, it's relatively mobile, and it's going to link different ecosystems. Within this framework, we have donor ecosystems, for example, that are important for controlling processes in adjacent ecosystems. This is an example of nitrogen inputs for major watersheds of the world. And you can see, here's anthropogenic nitrogen inputs, kilograms per kilometer squared per year, so how much nitrogen deposition there is, and these are nitrogen outputs. And in general, there's a positive relationship between how much nitrogen output there is on an area basis and how much input there is, but also a lot of variation that occurs across these ecosystems. Essentially, this is quantifying some of the impacts that we have on ecosystems by changing rates of inputs, and then the effects that they have on how much nitrogen is output from that system. So this links some of the human impacts with the functioning of the system in it that gets all the way into the water, but then also think about for nearshore coastal environments that are going to be downstream of these areas, receiving different amounts of nitrogen because of things that are happening upstream and how much inputs we have to that system. Another factor to think about is erosion. And with erosion, we're going to have movement of materials from one patch to another. Now with mass wasting, for example, you get a situation of relatively local movement of material, but we also have atmospheric transfers that can be important as far as dust is concerned. So we have erosion and movement of eroded materials physically and also in waterways, but also it gets into the atmosphere. An atmospheric transport of gases and particles links ecosystems over the largest distances and at the coarsest spatial scales. So for a watershed, that's going to be relatively local, but once things get into the atmosphere, it can link areas at even greater distances. So here we have the atmospheric transfer of gases and solutions and particulates among ecosystems. We can think about fertilizer, nitrogen being added to a system, and it's taken up by crops, and some of that is going to get into the groundwater and move across ecosystems. And here we go from a source region to a sink region. But also, we're going to have trace gases that are produced that go up into the atmosphere and then are deposited downwind in a sink region. And if there's more utilization of that nitrogen than there is loss via gaseous loss or leaching, this really becomes a sink. But these two systems can become linked in at least in a one-way flow, going from source to sink. The consequences of the differences in nitrogen deposition are going to vary across ecosystems, but also with how much nitrogen deposition you have. So once nitrogen starts to move across systems and become deposited, we're going to see a whole host of changes. So for example, on the x-axis we have a stage, and this is really a stage of eutrophication or a stage of how much nitrogen deposition there is. And then here's just relative units of the different processes that are occurring. So for example, for successional or end depositional stages, we're going to have increases in nitrogen mineralization, then they might decline a little bit, while foliar nitrogen might go up. NPP also increases to a certain point. Then there's a whole host of other changes with soil C/N ratios, methane consumption, nitrification, and leaching, as well as production of nitrous oxide. In addition to nitrogen moving through the atmosphere, we also have acid rain. And so acids that are produced, such as nitric acid and sulfuric acid, when it enters the ecosystem, it not only brings with it nitrogen and sulfur, but it also brings with it protons. And as those acids move through the system, it's going to leach out cations like calcium or potassium. And so the downwind effects going from source to sink ecosystems for acid rain is really going to have effects on the cation availability. So that's one way where linkages among ecosystems can lead to depletion of cations. But on the other hand, dust also returns cations, and certain types of erosion in other systems is going to deposit minerals on the surface of the ecosystem and return cations. So atmospheric linkages of different ecosystems can lead to the depletion of cations or their increase, depending on the type of atmospheric connections that we have. So places that receive a lot of dust can receive a large influx of cations. In addition to water and material, energy is also transferred among ecosystems. And this is a representation of a process we had seen before, looking at the interactions between adjacent areas that are either under crop or natural vegetation. And what we get are differences in albedos, for example, that occur in crops and natural vegetation. Above the natural vegetation, you have high sensible heat flux, and that leads to increases in air temperature and rising air. As that air rises, it's replaced with air that is coming across croplands, and these have much higher evapotranspiration, and so they put a lot more water vapor into the air. That relatively moist air is sucked up over the natural vegetation due to increases in the sensible heat flux, and so with it, clouds are produced, and then air cycles back after it rains that are drier. So dry air is subsiding, moist air is rising, and that's an interaction across different patches. When it happens on a scale, when these patches occur on a scale large enough to affect circulation, we're going to see differences in precipitation, increases in precipitation over the natural vegetation, and decreases over the croplands. And that only becomes apparent or only starts to happen once those patches are of a certain size. In addition to there being hydrologic links across ecosystems and atmospheric links, we can also have biotic links across ecosystems, and animals link ecosystems. So we had an example of an Arctic tern really early on in this course, And because of their large-scale migrations, we can have linkages across the most disparate ecosystems on Earth. So at the opposite ends of the poles, we're going to have movement of animals across there. They're going to bring with them materials, for example, that has a direct ecosystem impact, but also some of the dynamics that happen up here are going to change the abundance of those terns, and that's going to impact how many moves to the southern hemisphere and impact those regions. Animals such as seabirds are going to bring with them nutrients from their surrounding areas, such as the seas, and the input of nutrients are really important. In a bare rock system, not that important, but you'll remember that we also talked about on islands, Aleutian Islands, that the presence of foxes decreased seabirds. And with that happening, there was a lot less nutrient input to those islands and much different vegetation. This is an example of how thick some of these guano deposits could have been. And these were areas where there had been enough nutrient deposition from the seabirds to actually accumulate and be mined, mostly for its phosphorus content. Now there's a whole host of other animals that also bring with them nutrients. And another example tends to be salmon that go upstream and with them bring nitrogen and most importantly phosphorus from the ocean. And it's a large-scale fertilization effect as they move upstream and they eventually die. It's a fertilization of that environment that leads to increases in primary productivity of the stream, which then leads to increases of food abundance for the offspring of these fish. So we have a whole host of linkages that can happen at a broad set of scales. And as a consequence of this, when we think about the dynamics of an ecosystem, we can't think of the dynamics of an ecosystem without thinking about the connections among ecosystems, whether those connections are atmospheric, hydrologic, or biotic.